Welcome to Chemistry World. Today we will see Walden Inversion. What's about the Walden Inversion? The inversion of configuration observed during an SM20 reaction of a substrate in which the carbon atom bearing the leaving group is chiral. It is called Walden inversion or umbrella inversion. See below. For example, this is the chlorobutane. The chlorine attached to second carbon. This chlorine attached to the second carbon. So this chlorobutane going to 2-iodobutane. This is turning umbrella inversion. When attack iodine, the inversion is 2-iodobutane. This is the 2-iodobutane. In this conversion, 2-chlorobutane going to 2-iodobutane because iodine is more electronegativity than chlorine atom. That's why the electrons pulling the from this carbon. See below. See, note, this is the second carbon. Okay, that is why we given 2-iodobutane and 2-chlorobutane. This is 2, this is 2. Next, in the S1 reaction between iodine ion S2-chlorobutane, a backside attack by the nucleophilic causes Walden inversion. The product is R2-iodobutane. This is the backside attack by the nucleophilic causes. See below. This is called S1. See? This is carbocation racemic mixture. S1 SN1 carbocation racemic mixture. Here this is the chiral carbon because it is 4 different group in there. This is carbon carbon or asymmetric carbon. This is going to achiral carbon because this carbon attained positive charge. See below. In this carbon has 4 different bulky group. So chlorine is going to outside as a leaving group. This chlorine going to as a leaving group. It is called a nucleophilic. After formed carbonium ion, OH group is going to attack the carbonium ion. OH group is coming to attack this carbon ion. OH means it get OH minus. This minus negative charge going to attack this positive charge. This OH group, it is a one negative charge. Carbonium ion, it is attack the maybe upside or downside. If you going to attack downside, this is downside, this is the upside. So we get DL mixture, dextro and levo mixture. If asymmetric carbon or chiral carbon proceed at S1 reaction, we getting racemic mixture D and L, dextro and levo. If asymmetric carbon or chiral carbon proceed at S1 reaction, if substitute size inversion in configuration. For another example, see below this example. This is the 2-bromobutane, 2-butano. So this bromobutane attain the equilibrium condition. It is going to attain the equilibrium condition. Here we are going to nucleophile or living group. See, this is S configuration, this is R configuration. Here bromine is going to living group and S2-bromobutane going to R butanol. This S-bromo going to R butanol, sorry, R butanol, NaL. This is the NaL, sorry, I written mistakenly. This is R butanol. This is S-bromobutane. This is the transition state. See, the bromine is going to living group. So because bromine is as more electro negative element, that is going to living group. So bromine is going to living group and S-bromobutane going to R butanol is S configuration going to R configuration. This is the Walden inversion. Next, Paul-Walden cycle. How to interconvert of the dextromalic acid and levomalic acid. See the interconversion. This is the plus chlorosuccinic acid when treated to SN2OH or PCl5, we get minus malic acid levo form. This is levo, this is a dextro. This is the malic acid. This is chlorosuccinic acid. This is going to convert malic acid when treating SN2OH and PCl5. This part only SN2 process, this part only, this circle part only SN2 process. Again we had Ag2O or H2O. This is, it gives plus malic acid. This plus chlorosuccinic acid convert to, when treating Ag2O with H2O, it is convert to plus malic acid dextro. This is the plus malic acid. SN2 process, this condition attain the equilibrium. SN2 process with the PCl5, this plus malic acid going to again minus chlorosuccinic acid. This is lever form, this is a dextro form. This chlorosuccinic acid again going to minus malic acid, lever form. After adding Ag2O with H2O, this plus C more again, this plus chlorosuccinic acid when treated with SN2OH PCl5, it gives minus malic acid, lever form. This plus chlorosuccinic acid when treated with Ag2O with H2O, it gives plus malic acid. This is a dextro form. Again, this plus malic acid when treating with SN2 process with PCl5, this is convert to again minus chlorosuccinic acid. This is lever form. This minus chlorosuccinic acid when treated with again Ag2O with water, it gives minus malic acid, lever form. Here this part is the SN2 process. See, PCl5 is a chlorinating agent. It is displaced the OH group and going to attach the Cl. Please remember this. PCl5 is the chlorinating agent. It is going to replace the OH group. Next, Phillips Kenyon cycle. This is also Walden types of inversion. For example, 1-phenyl 2-propanol react with para-toluene sulfonyl chloride to give the sulfonate ester. This is special name is called tosyl group. This is the tosyl group. See, this is the, because here sulfur is attached, that is why this is one of the functional group. It is called tosyl group. See, this is further reaction with the ethanol and K2CO3. It gives the ethyl ester with the inverted configuration. This is going treated with para-toluene sulfonyl chloride. It gives ETOH, ethyl alcohol. This alpha means specific rotation. This specific rotation is 133 degree. This specific rotation is 131 degree. It gives, this is KOH alkali base. It is dissociate K plus and OH minus. This OK, it means potassium salt. This O is going to replace the H. Again it gives ethyl bromide when treating with ethyl bromide. This is the potassium salt. When treating with again ethyl bromide, again it gives this production. This specific rotation is 123.5 degree. This part is retention part. This molecule, when treating with SN2 reaction with ethyl alcohol ETOH and K2CO3, it gives this is the Leva form. This specific rotation is minus 20 degree. This part is inversion configuration or Walden inversion. This part is retention part. Please, if don't understand, watch again this video. This whole part is called Phillips-Kenyon cycle. Note, if S1 reaction, it is racemization. If S1 SN2 reaction, it is inversion. Please note again, if SN1 reaction, it gives racemization. If SN2 reaction, it is give inversion product. This is a S1 reaction is gives racemization product, and SN2 reaction is gives inversion product. Please subscribe to the channel. More videos on the way. Thanking you all.